Question number 5 is, if velocity, acceleration and force are taken as fundamental quantities instead of mass, length and time, then the dimensions of Young's modulus would be. So basically we have a set of fundamental quantities, mass, length and time, which we usually use while solving our problems, but now they're setting a new set of fundamental quantities, which are velocity, acceleration and force, and they need the dimensions of Young's modulus in those terms.
In terms of the new quantities.
Exactly.
Yep. So the basic thought process in this question according to me would be कि जो अपना original वाला, that is mass, m, length and time, उसको find like mass is equal to something in terms of the new quantity, ताकि if we know the formula in terms of the original quantities उसमें बस डालना पड़े. I'll show it to you.
Okay.
It is not very difficult, just go on. It will be very easy if you follow it in a systematic procedure. हाँ ठीक है. तो सबसे पहले velocity is equivalent to length into t to the power of minus 1.
Yes.
And acceleration is equal to L t to the power of minus 2. So if we divide both of them, that is A upon V is equal to t to the power of minus 1. Therefore, हमें पता चल गया that time is equal to velocity upon area.
Yes.
So now we know time in terms of velocity and area.
Cool.
That is the new fundamental units.
Right.
Now we can also find length equal to V square upon A using this formula over here. We know length, we know velocity, we know time.
Yes.
ठीक है, अभी ये भी मिल गया हमें. Now we use force is equal to m l t to the power of minus 2. तो इससे आ जाएगा mass into acceleration. So therefore mass is also equivalent to force upon area. Sorry, acceleration.
Yes.
Where so now we have all the three fundamental quantities in terms of the new quantities.
Okay.
So if you give anything to us, we can just solve it.
Right. So what is given to us is Young's modulus. So Young's modulus, we already know that it's F by A.
Yep. We know it using the formula.
Yes.
Young's modulus into delta L upon L. Where this is the strain is equal to stress.
Yes.
So therefore equal to force upon area.
Right.
So this is dimensionless because obviously everyone knows this.
Yeah.
But still I'll just write it down.
Right.
So therefore Young's modulus is equal to force upon area is equal to m L t to the power of minus 2 upon L square equal to m L to the power of minus 1 t to the power of minus 2.
Yes.
And we already know the dimensions of m, L and t.
In terms of the new dimension.
In terms of the new dimension.
Right.
So mass is equivalent to F upon area. So we'll just write it down over here. F upon A into L, which is equivalent to V square upon A to the power of minus 1 into time, which is equivalent to V upon A.
Yes.
To the power of minus 2.
Yes.
So this thing comes out to be F into A square upon A into V square into V square. Do all the steps slowly, okay? Don't like jump and like don't skip this step over here.
Right.
Because while in the exam, if you skip this, then there is a chance that you might have some problem.
And
So
there might just be another option which is
this is what the people do in IIT.
Yes.
They are expert at exploiting your weaknesses. A square V to the power of minus 4. So this is the C option.
Okay. So basically you employed one method of solving this question where you found out the basic fundamentals dimensions in terms of
the new ones. Yep.
Yeah. Instead of finding the new ones in terms of the basic ones, which should require you to do it for multiple times, more number of times.
Like what some people do is that they take out Young's modulus first, they find it force upon area. So what they do is force हमें पता है ठीक है नया है. So they just write force over there. And area को they find it out in terms of what do you call it, velocity and acceleration.
Yes.
That becomes a little bit of a hodgepodge.
Right,
So instead of that, follow this procedure. It'll take you some more time, but at least it will be foolproof. तुम्हारा आंसर हर बार आ जाएगा. And exam में यही problem होता है. People get stressed out. There is less time.
Right.
And another thing where people go wrong is over here acceleration is written as capital A, and we also know that area is also capital A.
Exactly.
So in this thing over here, like force upon area, here don't take it as acceleration, okay?
Right.
Take it as area. So this is a small mistake which people can do under pressure.
Exactly. So as a tip, we would say that we can write down area or something when we need to solve it out.
Yeah, but if required.
Yes.
Otherwise, we're finding the dimensions always converted.
Right. Exactly. So here the question was the dimensions of Young's modulus in the new dimension set would be option C. Am I right?
Yeah, awesome.
Right.
Correct.
So this is question number 5. So question number 6 says the dimension of half epsilon naught E square, where epsilon naught is permittive of free space as we know. E is electric field. So we need to find the dimension of this particular expression. So what I believe is half is dimensionless, and it shouldn't matter for us for us while we're finding the dimensions of half.
Yep, exactly. You can put in any number, any
Yes.
sinusoidal function, anything which is dimensionless. It won't make any difference.
Right. So let's go ahead with this problem.
Okay. In this we need to find the dimensions of epsilon naught and E,
Right.
as anyone would do it.
Uh-huh.
So, but the thing over here is that do not find the dimensions of epsilon naught in terms of m, l, like m to the power of x, l to the power of y.
Okay,
Don't do that. Okay.
Uh-huh.
Find some formula in which epsilon naught is used, and find some other formula in which E is used,
Okay.
and then relate them,
Right.
as I'll show you.
So we
Because
need to recall the formula which we know already.
Yeah,
which
yeah,
we
yeah,
used.
yeah.
Okay.
So the first formula that comes to our mind while thinking of epsilon naught
Uh-huh.
is equal to force between any two particle charges.
Yes.
That is 1 upon 4 pi epsilon naught into q1 q2 upon r square,
Yes.
where r is equal to distance,
Yeah.
and so its dimensions is l.
Yeah.
ठीक है, so हमें ये पता चल गया. So therefore epsilon naught मिल जाएगा q1 q2 upon 4 pi r square into f.
Yes.
So this thing again is dimensionless.
Perfect.
So we do not need to bother about it, but ठीक है, लिखने को लिख दिया.
Okay.
ठीक है. Now secondly we need to find some formula in which E is used. So E is equivalent to, like we know force is equivalent to QE.
Yes.
So इससे E आ गया हमारे पास.
Yeah.
E is equal to force upon Q.
Yeah.
अभी हम replace करेंगे.
Uh-huh.
That is epsilon naught into E square.
Yeah.
तो Q square upon R square into F. This is, I'm writing epsilon naught क्योंकि Q1 Q2.
Right.
You write it in terms of the dimensions.
Dimensions. Yes.
Upon 4 square upon into 4 square upon Q square.
Perfect.
ठीक है. Now cancel it off.
Yeah.
Like force will get cancelled off over here. Q square will get cancelled off. Now when you arrive at the final thing, that is F upon R square,
Yes.
तभी replace the dimensions of force and radius.
Oh.
What someone would do is ठीक है, यहाँ तक आ गया, फिर they would replace Q, they would replace F, and then they would cancel.
Okay.
So instead of that, find the formula first and then replace it.
Perfect.
That will be faster and easier.
Yes.
So force, as everyone knows, is m l t to the power of minus 2 upon l square
Yes.
is equivalent to m l to the power of minus 1 t to the power of minus 2.
Perfect. So this is the dimensions of half epsilon E square, right? So basically, again, what we need to remember from this question, as we remember from all the questions,
Huh.
is that we need to remember some basic formulae, right? And we need to think that fine, there is epsilon naught, there is E, so we need to interlate those two, and cancel out a few expressions.
It's a very easy question, and it came in JEE. They keep on asking these kind of questions कि Boltzmann constant का निकालो, इसका निकालो, उसका निकालो.
Okay.
This is a basic fundamental thing which everyone should know. Like this is the approach.
Right.
तो
right.
ऐसा सवाल आएगा JEE में, तो you should obviously score it. It's a very easy thing.
And it's not time consuming.
हाँ, it's
at
not
all
time
if-
consuming
yeah,
at all.
If you know that epsilon
Very
naught
good
is
question to score in JEE.
Right. So finally, the question would be m l power minus 1 and t power minus 2, right?
हाँ जी.
Yes. So this is question number 5. Number 6.
6.
So question number 7 says, a wire has a mass 0.3 plus or minus 0.003 grams, radius 0.5 plus or minus 0.005 millimeters, and length 6 plus or minus 0.06 centimeters. So what we need to find is the maximum percentage error in the measurement of its density. So the options are 1, 2, 3 and 4. So yes, how do we start off? We start expressing density in
Yeah.
terms of mass and
Mass, radius and length.
Right.
So first we need to find the formula of density.
Uh-huh.
So density, as everyone knows,
By
is equal
definition.
to mass upon mass per unit volume.
Yes.
And this is a wire. So wire has a cylindrical shape.
Yes.
So therefore mass upon pi r square L.
Where R is radius and L is the length.
Yeah,
of it.
perfect.
Right.
So we know the percentage error in mass,
Mhm.
we know the percentage error in radius,
Yeah.
and the length. So we
Okay.
can find the percentage error in density.
Right.
So let x be denoted by density.
Mm-hmm.
So therefore delta x upon x, where this is the fraction, this is the error, so this thing becomes the fractional error in density,
Yes.
is equivalent to delta m upon m plus 2 into delta r upon r.
So 2 into delta R by R is because R is raised to the power of 2 in the expression, isn't it?
Yep, awesome, correct.
Right. So any for example, if it's b square or b cube, it has to be 2
3
into or 3 into, right?
Yep.
Yeah.
The one thing which we have to take care is that write the units also. Like
Okay.
mass is measured in grams, so
Uh-huh.
it will get cancelled off. But still, it is a good practice to write it.
Okay,
Like
just to
gram
make
over-
sure
just to
without
make sure.
errors, yeah,
Uh-huh.
error free.
Because see, in this question, radius is measured in millimeter,
Yes.
length is measured in centimeter. So you might just go wrong, like under a pressure situation, or if you're
Right,
doing
right.
it very fast.
Uh-huh.
This is always a good
Habit.
habit, yeah, good
Yes.
practice.
Mm-hmm.
2 into
0.005, 0.5. Yes, so basically we don't have to convert millimeter into centimeter or
Mhm.
take any effort towards
it
that.
will cancel off. It does
Yeah,
not matter actually.
Exactly.
Huh.
Fine.
So this will come out to be 0.01 plus 0.02
Mhm.
plus 0.01 again.
Yes,
Yes.
perfect.
Obviously,
Uh-huh.
so this comes out to be 0.04 into 100. Will give you the percentage error, yeah,
Which is 4%.
4%. So
Perfect.
therefore, option number D is correct.
Right. So here what we need to remember is that when both the tolerance level and the initial 0.5, which is given, for example, in the radius, if it's in the same metric, for example, in a millimeter or in centimeter,
Same units.
same units, my bad. So you need not convert it or waste your
हाँ.
time towards that.
And एक चीज याद रखना कि formula को याद रखना, because most of the people, the question is very easy, and this
Mhm.
question came in JEE itself.
Right.
But still, a lot of people are not able to solve it because they do not remember this formula.
Right.
So ये formula बस याद कर लो and it will be very easy.
Right.
The easiest 3 marks that you can score in JEE.
Okay.
But still, surprisingly, a lot of people don't do that. I don't know why.
Right.
So-
So the question number 7 was maximum percentage error in the measurement of density, which is option number D4. So that's question number 7 for you. So let's take up question number 8. So this says that a physical parameter A can be determined by measuring the parameters B, C, D and E using the relation A equals B power alpha C power beta by D power gamma into E power delta. So if the maximum errors in the measurement of B, C, D and D are given to be B1%, C1%, D1%, E1% respectively, then the maximum error in the value of A would be. Okay, so for now, let's just from the given question, we'll understand that alpha, beta, gamma and delta are dimensionless. As we have already studied, that whatever power is raised to, it is
They are the
dimensional.
powers.
Exactly.
They're just basically numbers.
Right.
तो सबसे पहले तो मैं ये बोलूँगा कि क्वेश्चन इतना लंबा लगता है, इतनी सारी चीज़ें, अल्फा है, बीटा, गामा, परसेंटेज एरर्स, इट लुक्स अ लिटिल स्केरी कि भाई करे नहीं करे समझ में नहीं आता. बट थोड़ा सा करने की कोशिश करो, हो सकता है बहुत इजी हो.
Okay.
तो मैक्सिमम एरर डेल्टा ए का
Mm-hmm.
अपॉन ए, दिस इज द फ्रैक्शनल एरर और द परसेंटेज एरर,
Right.
इज इक्वल टू अल्फा इंटू डेल्टा
B.
बी अपॉन बी
Right.
प्लस बीटा इंटू डेल्टा सी अपॉन सी
Yes.
प्लस गामा इंटू डेल्टा डी अपॉन डी
Uh-huh.
प्लस डेल्टा इंटू डेल्टा ई अपॉन ई.
Perfect.
सो वी नो दिस फॉर्मूला कि जो भी पावर हम रेस करते हैं
Mhm.
वो यहाँ पे मल्टीप्लाई हो जाती है.
Yes.
कि b की पावर अल्फा है तो अल्फा मल्टीप्लाई कर देंगे, c
Right.
की पावर बीटा है वो कर देंगे. तो ये फॉर्मूला बेसिकली हमें पता है और लॉजिकली भी देख सकते हैं अगर याद नहीं हो तो.
Right.
अब तो सिंपल हो गया क्वेश्चन. हमें पता है कि डेल्टा बी अपॉन बी
Is
इज इक्वल टू
already
B1.
Right.
परसेंटेज है तो हम बाद में मल्टीप्लाई कर देंगे.
Right.
B1 प्लस बीटा इंटू C1
plus gamma into E1 plus delta into E1. Right. So this is the maximum error in the value of A.
yep.
Okay.
एंड परसेंटेज में परसेंटेज से मल्टीप्लाई कर देंगे. फिर रिक्वायर्ड इनटू 100
Uh-huh.
इज इक्वल टू अल्फा B1 प्लस
Plus
gamma D1 प्लस डेल्टा E1
percent.
परसेंट.
Okay.
इसको परसेंटेज से भी मल्टीप्लाई हो जाएगा यहाँ पे इनटू 100.
Uh-huh.
तो
So this is the maximum error in the value of A.
A.
So this is a pretty simple question, but what you're saying is we shouldn't get intimidated by
हाँ,
the fact
it
that
is a little scary question.
Right.
And काफी सारे variables हैं.
Uh-huh.
And basically this question's purpose is कि formula याद रहे कि power है तो multiply कर दो.
Okay,
इतना
okay,
सा
okay,
लेके
okay.
चलोगे तो IT में it will help you along with.
Right. Again, so the basic formula which we have to remember is this.
हाँ.
It says that if there is something raised to the power, then we should multiply that with the percentage.
It's a very simple thing. Power है तो
Hmm.
multiply कर दो, simple.
ठीक है.
And this thing should be plus over here everywhere.
Right.
Never हम subtract it कि divide हो रहा है तो subtract कर दिया नहीं.
Oh, okay. So we also have to keep in mind that if gamma is in the negative power, we shouldn't
हाँ.
have a negative.
Like over here gamma अगर हम ऊपर ले जाएंगे d को
Uh-huh.
so it will be d to the power of minus gamma.
Right.
तो जितना भी एरर रहता है हमें सब कुछ ऐड करना है. ये नहीं कि इधर 10 हो रहा है उधर -10 हो रहा है तो 0 एरर कर दिया. ये तो बहुत बहुत ही
right.
illogical है. So it is all simple logic.
Okay.
धीमे धीमे करो, intermediate मत हो, and
Right.
you'll score easily.
Perfect. So this was question number 8, and the maximum error in the value of A was alpha B1 and beta C1 plus gamma D1 plus delta E1%. So this was question number 8. So we have question number 9, which says a physical quantity P is given by the formula P equals A cube B square by D root C. The percentage error in the measurement of A, B, C and D are given to be 1%, 3%, 4% and 3% respectively. And now let's have a look at the options, and also keep in mind the fact that the question is a multiple correct option answer. Right, so we have the maximum percentage error in P, and they have the option A and option B pertains to that, and option C and D pertains to the maximum error which is contributed by say measurements of B and C. So yes, I assume that we have to follow the age-old formula.
Yeah, the age-old formula, the
yes,
basic thing. Delta P upon P is equivalent to 3 into delta A upon A.
Yes.
Plus
2 delta B by B plus 1 into delta D by D plus, since it's the root of C, it's half into delta C by C. Right. So we already know this that delta A by A is 1%.
1%.
Yes. And delta B by B is 3%. And delta D by D is also 3%, while delta D C by C is 4%.
The only mistake that you could do over here is that in the values 4 is written before 3. So here, instead of this delta D writing it as 3, you might write it as 4. That is a mistake which you can do in a hurry. So take care of that, like replace the values properly.
Okay.
So 3 plus 6 plus 3 plus 2 sums up to be 14%.
Right.
So all of these were in percentages, so this will also be in percentage.
Right. So let's look at the options again. We have A and B pertaining to maximum percentage error in P, and we have that the maximum percentage error in P is 14%. So we can take this option and rule out this option. Right.
Very true.
Okay.
And there might also be a case in JEE where none of A and B are correct.
Okay.
A would be 10%, B would be 11%.
Right.
So don't get panicky. Like what we start doing is we start to question our own thought process. So if you are very confident about it, go with it. It might be a single correct answer.
Right. And maximum error is contributed by which measurement is what we need to find out.
The second part, yeah.
So okay, let me say that 3% is the contribution by A. 6% is the contribution by B, 3% by D, and 2% by C, right?
Yeah, correct.
So the maximum number over here is 6. Which pertains to B. So again, we can easily find out that C is the right option since it's contributing majorly to the percentage error in P.
And D is the incorrect option.
Right.
So over here we have to see the powers also. Like you could have also directly done it by multiplying it in your head, but this is obviously a foolproof method.
Right. Instead of making errors while substituting the values.
Substituting the values.
Yes.
So one thing which can be learned is that the powers also matter, because if you see the like the error in D is in C is maximum, but still the option of B is correct because it is being multiplied by 2.
Right.
So if you don't know this formula, then it is very difficult to get it correct. But if you know this formula, it becomes very easy.
Exactly. Again, I would like to reinstate the fact that this is the formula which has been helping us a lot in questions pertaining to units and dimensions.
And the percentage errors.
Yes, especially.
And this is what JEE people like to ask.
Okay.
This and vernier calipers. Vernier calipers and screw gauges.
Right.
Like every year almost you'll get at least one question out of the 3.
Okay.
Which is very easy to score.
Okay, so this is that's because we have practical applications of that. Right, so that is question number 9 for you with options A and C as the right answers.